All right, we're going to start Unit 12. Unit 12 is over solutions. This video is going to cover the first two building blocks for Unit 12. The first building block is over the properties of water. And your learning goals for this week are to list several unique properties of water and explain why the properties are important and relate these properties to water's polar nature. All right, so the first thing that we're going to talk about is water's polarity, because water's polarity is easily the most important characteristic. And the reason for this is because a lot of the other characteristics that we talk about are results, or they result from water being a polar molecule. So these characteristics that we're going to talk about in a minute are hydrogen bonding, and then the adhesion and cohesion that result from hydrogen bonding. We're also going to talk about the fact that water is a universal solvent and the fact that it has a high specific heat capacity. But again, we're going to hit on each one of those on a different slide here coming up. But before we do that, we need to have a reminder about what polarity is. So we've talked about it a little bit before when we were drawing the pictures of molecules earlier in the semester. And remember that polarity results from an uneven distribution of electrons that are surrounding a molecule. So we have, in the case of water here, we have water with its little slight negative charge here. My pen's not working very well. I'm going to circle that. And that little symbol, remember, that means that it's a partial charge. So it's not a full-on charge like you'd get with an ion, you know, a charged atom that's forming a compound. It's just kind of a little partial charge. And then if you take a look down here at each of these hydrogens, you'll notice that each hydrogen has a slight positive charge. And this is because oxygen, being more electronegative, is hogging the electrons or pulling them away from the hydrogens. And so the result here is that we've got one end of a water molecule with a slight negative charge, and the other end down here where the hydrogens are with a slight positive charge. So it has opposite poles. And this is also a result of water being a bent molecule. So it's that bent or angular shape, and that coupled with the fact that oxygen's really electronegative and it hogs the electrons is what's making water a polar molecule. So the first thing that we're going to talk about that results from water's polar nature is hydrogen bonding. And a hydrogen bond results from the attraction between the positively charged region on one water molecule and a negatively charged region on another water molecule. So this is how water molecules are kind of attracted to each other. And you can almost think about them as being almost these little teeny tiny magnets. Where you've got one positive end being attracted to the negative oxygen on another water molecule. So they kind of want to stick together. And so the results of this, we have two things that we're going to talk about. We have cohesion and adhesion. And cohesion is where water molecules have an attraction for one another. So this is where water molecules tend to clump together. And if you look at this little picture up here with the little leaf with the water droplet on it, the reason that water droplet is balling up into a droplet like that is because all the water molecules are trying to stick together, and that's the easiest shape for them to form when that's happening. Another thing that cohesion creates is surface tension. So if you picture, if you have a cup of water in front of you, the top of that cup, really all the water molecules in that cup are sticking together, but the layer of water molecules across the top, if you can think of them as kind of, holding hands, they're sticking together, it takes a certain amount of force to break through the surface of water. And it's a little bit more force than it would take to break through the surface of alcohol, where we have molecules that are not sticking together. So that's why some bugs, water striders, can walk on top of water, because they're light enough, they don't have enough mass to be able to push down through the hydrogen bonds. This also makes water somewhat viscous. And remember before when we talked about viscosity, we said that it was a resistance for a fluid to flow. And so water, its molecules wanting to stick together, tends to somewhat resist flowing. So if you were to take a cup of water and tilt it over, you would notice that it kind of rolls up along the side. It kind of almost, like it does with these water droplets up here, kind of forms a wall where it doesn't really want to flow, but because there's so much of it, it's being forced out of the glass. If you were to do the same thing with alcohol, you would notice that the alcohol just slides right out of the glass very easily. It looks really different if you get down close and pay attention to that. Now, adhesion is the tendency for water molecules to be attracted to other types of polar molecules. So in this case, we've got an example down here. If you've ever given blood, then you might notice that sometimes they take these little teeny tiny glass tubes, and when they touch it to a drop of blood, it sucks the blood right up into the tube really quickly. Or even an example that we've seen in chemistry is when the meniscus forms in a glass graduated cylinder, it's because water molecules are clinging to the surface of the inside of that graduated cylinder. And it's the same case here with these little tiny tubes that they use in laboratories or medical laboratories. This is called capillary action. And what's happening again is the water molecules, they're attracted to the molecules on the inside of that tube, and they're pulled up. And the more narrow that tube is, the farther up they can be pulled. And this is how plants are able to pull water up from the ground all the way up to the tops of some really tall trees, is through capillary action. All right, let's move on. All right, the next thing that we're going to talk about is the fact that water is a universal solvent. And again, this results from water's polarity. And what a universal solvent means that it's really good at dissolving lots of different kinds of things. So the two main categories of things that can be dissolved by water are ionic substances and polar covalent substances. And the reason why ionic substances are very easily dissolved by water, or most of them, not all of them, are because they have, or they're composed of these positive and negatively charged particles. So we take a look at this picture right over here. You can see, this is an example of sodium chloride. So we've got, sodium atoms with a positive charge and chlorine atoms with a negative charge. And water molecules will come over and they will start to surround and work their way in between these different atoms, and they'll surround them. So this negative part right here you can see is kind of surrounded by a bunch of hydrogens on these water molecules that are surrounding them. And over here, if you take a look at the sodium with a positive charge, all of the oxygens on these water molecules are facing towards that positive charge. So when something dissolves, you've got these particles that are surrounding all the other particles, the water molecules surrounding them. And that's happening because water is polar. It's got those slight partial charges, and ionic substances are made of charged particles. The reason why a polar covalent substance can dissolve in water is because although they're covalent substances and they don't necessarily have full-on ion charges associated with them, they do have polar regions. Just like water is a polar molecule with a positive and a negative end, if a covalent substance, it has an uneven distribution of electrons, it can create polar regions on other molecules, and that allows them to be dissolved by water as well. And it would occur in the same way. So water molecules would surround those polar regions and separate those molecules from all the other ones that are just like them. And then a good example of that would be sugar dissolving in water, because it stays a sugar molecule, but water is surrounding its polar regions and moving it away from all the other sugar molecules. A good rule of thumb when you're trying to determine whether water will dissolve something or not is like dissolves like. So all polar substances can dissolve other polar substances, and non-polar substances can dissolve other non-polar substances. An example of something that will not dissolve in water would be water as a polar substance, and maybe an oil or butter or grease. Those are all non-polar substances. So polar substances do not mix with non-polar substances easily. The last characteristic that we're going to talk about is water's high specific heat capacity. So heat capacity is defined as the amount of heat or kinetic energy that 1 gram of a substance has to absorb or lose in order to change its temperature by 1 degree Celsius. Water happens to have a relatively high heat capacity, meaning that it can absorb a lot of heat energy before its temperature changes. And the reason for this is, again, because water is a polar molecule and it forms those hydrogen bonds. All these water molecules kind of want to cling together, and in order to overcome those hydrogen bonds and allow those water molecules to move around a little more, it has to gain enough energy to do that, and it takes a lot of energy to overcome all of those hydrogen bonds. So that's why water has a high specific heat capacity, and it's why water can be considered a good insulator. It's also really good at cooling our bodies. So when our bodies are hot and we sweat, the water that leaves our bodies, evaporates away, and it takes a lot of that heat energy with it. All right, this is the last slide for building block 1 over the properties of water. There's a help at home video here. If you want to watch another explanation from someone else, you're welcome to go ahead and watch that video as well. You can find it in the PowerPoint copy of this presentation that's found on It's Learning. Also, if you need help, my office hours for the next few weeks will be Tuesdays and Thursdays between 10 a.m. and noon. You can message me through It's Learning if you need immediate help. If your questions are not immediate or it's not during my office hours, you're always welcome to send me an email, and I will reply to your email within 24 hours during the week.